Good morning, everyone. First of all, thank you so much for joining this free live webinar on mastering earthquake analysis in ETABS. I hope all of you are doing great and excited for today's session. As civil engineer, we often learn concepts in theory, but understanding how things actually work in real-time projects is what actually industry expects. So today's session is going to give you practical insights into earthquake analysis and design execution in ETAP, so which is very important for every aspiring civil engineer. Before we begin, let me take a moment to introduce Bhavanam C2C. Bhavanam C2C is an ISO certified private limited company providing comprehensive consultancy to construction and corporate training services in the field of civil engineering. We are specialized in dealing with architecture, structural, and construction management courses, which were delivered by IIT gold medalists and highly experienced industry professionals. We are a team of skilled people striving for better students and working for a professional community in the civil world. We share our knowledge and industry experience with our upcoming civil engineers to build a strong foundation to their career and to convert their dreams into reality. With a commitment to excellence, we have trained over 10,000 plus students, helping achieve significant career milestones through our extensive training programs. Now, coming to the most important part of today's session, let me introduce our speaker for today. We are delighted to have Mr. Biswas sir with us today. He is a structural engineer with over experience 6 plus years in structural field. He has strong expertise in design and execution in earthquake analysis and all, and has been actively involving in guiding the students and professionals with practical industry knowledge. We are really excited to learn from his expertise and insights today. So, without taking much time, I would like to hand over the session to Biswas sir. Thank you so much for joining everyone once again, and it's over to you, sir.
So thank you so much, first of all, to Mr. Pavan for giving me this platform to share my experience and expertise in different area of earthquake engineering. And a great gratitude to Bhavanam C2C as well for this opportunity. Wish you a very good morning to all of you. Myself, Tathagat, as you have got to know from Mr. Pavan. Today, we are basically going to have a idea about the earthquake engineering. We have got to know many things, many says, many discussions in our childhood related to the earthquake, right? Whenever earthquake, the word earthquake we listen, we have a lot of things in our mind. But how this all these things can be simplified and it can be applied to the actual projects in accordance with the Indian Standard Code. Today we'll be having a quick glimpse of that particular area. So, first thing first, I'll start with the basic understanding of the earthquake first, okay, in accordance with our Indian Standard Code. I believe all of you are, there with us in this particular session. And I would also request all of you to keep a pen and paper handy so that you can have a notes and quick, scribbles in your paper, right? So, as per Indian Standard Code, it is 1893 Part 1 that we basically follow for earthquake analysis and design. And you all might be already knowing that there is a new code that has been launched recently in 2025, but that code has been withdrawn for certain reasons. So as of now, we are particularly having this 1893 Part 1 2016 code only to follow with for the earthquake analysis. Today we'll be specifically discussing about two areas of earthquake analysis. One is linear static analysis, another one is linear dynamic analysis, which is response spectrum method and equivalent static method. Now, uh, earthquake, whenever we listen the word called earthquake, we have always in mind that it is a dynamic thing. It can never be a static thing. Static means what? Generally, it will be a static load, which is dead load, live load, which is just there, which does not have any kind of impact or any kind of dynamism in it, right? So how the static earthquake, this particular word comes up, there is how it can be called as static earthquake. Okay. So I just explain this particular area first because many a times I have seen many students, many trainees got a little confused with this, that what exactly called as equivalent static method of earthquake analysis. Okay. So in any kind of structural mathematical model, it could be in any software, that it could be in ETABS or any other places. Most of the time, what we do is we just model the portions which is related to the structural members. Like let's say for an example, structural beams, structural columns, structural slabs. we generally do not model any kind of infill wall panels. Infill wall panels means the brick walls or the block walls or any kind of facade, glass facades or aluminum facade or any kind of facade sort of a thing. We do not generally model. We take the load of it. Okay, we take the load of that particular wall on top of the beam, right? So it means what? We are taking the load consideration, but we are not modeling the stiffness consideration. Okay. So there is a difference between load and stiffness. Stiffness means physically to be present, and load means just the approximate load of that. Okay. So these two things are not same. Okay. So how this particular thing is basically changing this concept of static analysis. Now, if you do not consider the static analysis, what will happen? This infill wall panel stiffness, which will be actually there at site whenever the building will come up, definitely there will be certain kind of wall material, right? It could be brick wall or block wall or any sort of a wall. Apart from this beam and column and slab, beam column slab would be anywhere there. That is the frame of the structure. But on top of that, there will be actually the infill wall panels that will be coming up, and that is not in small amount of area. It will be a complete structure would be covered by the walls. Now, static method of earthquake is basically dealing with the codes. Code is having specific methodology, specific time period, specific formula through which we can create the static method of analysis. Like what we are trying to capture is we are trying to capture the effect of those infill wall panels as well. Because if we just model the beam column slabs and shear walls, and if we do the analysis and design directly with that model, this particular wall parameters stiffness would not be a part of it. Okay, it will be ignored by default. So that should not be done. Okay, that is incorrect because that particular wall material will also give us certain kind of lumped mass during the course of earthquake. Lumped mass means what? It will also contribute to lateral forces. Okay. So how to capture the effect of the stiffness of those wall parameters? Okay. We do not know how much stiffness that will offer. So for that, code has prescribed us certain methods through which we can extract the value of those stiffness as well as overall base shear, whatever is acting at the base of the structure, that base shear is basically being extracted from the model with the help of the method of earthquake force calculations from the code, right? So this is called equivalent static method, through which there are certain formulations through which we'll extract the base shear. Base shear means the total force exerted towards the building due to the course of earthquake, right? So that base shear calculation has been given in such a way by the code that this particular wall parameters would also be included as a stiffness as well. So static method is more specific, I would say, for the extraction of the base shear as a magnitude. Magnitude means as a value. If you ask me that, sir, response spectrum method or the linear dynamic method, which is more specific to the nature of earthquake, would be not enough. You need to again do the static analysis. The answer is yes. You need to do the static analysis. Then you need to move to the dynamic analysis, and then you need to match the base shear. Okay, I'll anyway come to the explanation of that area as well while explaining you a project to you. Okay, but at this moment, just I'm starting the session with this note that in order to do the just you remember this much, that in order to have the stiffness effect of the infill wall panels, the earthquake static analysis is must as per the 1893 part 1 2016 code. Now, what is the formula for that? The base shear, this is called VB, which is there in front of you right now. This is, as you know, that we have opened this code. Okay, and this is basically the page number 17, right? Okay, so what is the formula? VB equal to H into W. Now, what is H? What is W? H is horizontal acceleration, coefficient, right? And W is seismic weight of the structure, okay? VB is equal to base shear. Design lateral force is nothing but base shear. The total force that is exerted towards the building during the course of earthquake. Okay, that is the design lateral force or the base shear. It could be also stated as the resistance of the same force, because the resistance and the force should be equal and opposite. Otherwise, there would be no equilibrium, right? So it could be either resistance or the force. Both the things are called base shear only, right? Now, AH into W, what is AH, what is W? AH is a horizontal acceleration coefficient, which is related to different parameters. I'll come to that. And W is the seismic weight of the structure, right? So during the course of earthquake, what the lump mass that I mentioned earlier, including that whatever materials are there in the structure, including everything, whatever the lump mass are acting towards us, during the course of earthquake in the building, that is called, whatever the masses are there, that is called seismic mass or seismic weight. Okay. Now coming to the age, which is estimated as per 6.4.2 clause. Let's go to that 6.4.2, right? What is 6.4.2? Yeah. So this is the page number 9, right? So this place is basically stating the value of age. Design horizontal seismic coefficient, which is AH, right? So for a structure shall be determined as per this formula. Z by 2, A by G divided by R by I. Okay, or if I say in the other way, Z by 2, SA by G, I by R. Okay. So this is the formula for H. Now what is Z? Z is nothing but seismic zone factor, which is given by the code in table number 3. There are certain factors for different zones. You all know that there are 4 zones in our country: zone 2, zone 3, zone 4, and zone 5, right? Zone 1 is not there because after the Bhuj earthquake in Gujarat, the zone 1 has been dissolved in the year of, if I am not wrong, it is in the year of 2000 or near about that. Okay. After that, the new code has come up with this 2016 code has come up with the zone 2 onwards. There was no zone 1. That was there in previous code, but in the recent code, the zone 1 has been dissolved. Okay. So zone 2, 3, 4, and 5, right? So that all these 4 zones are having different zone factors, which is given in table number 3. You can refer it later on. Coming to the next parameter, which is I, importance factor. Importance factor is also, like, as you can see over here, it is written 1.5 for critical and lifeline structures, 1.2 for business continuity structures, where the occupancy of the building is more than 200 people, right? Like, so let's say for an example, certain tech parks or those kind of commercial spaces where certain offices are there, or some sort of a thing are there where accumulation of people could be more than 200. In that case, you can take the importance factor as 1.2, and 1 is for the rest of the part, like let's say any kind of a residential structures which is like little low rise or mid rise, or small structures, villas, and all the other places, you can take I value as 1, right? Next is R value, which is very, very important. It is extremely important. Please pay your attention to the fullest in this. Response reduction factor is directly dependent upon the ductility. Okay, now what is ductility? No, ductility is basically the elasticity sort of. It is like similar to elasticity without significant amount of deformation or significant amount of loss in its strength. Okay, so it is a elastic limit from where the particular material can come back to its own shape by completing one oscillation without significant loss of its strength. So that is called ductility. Means it can go or deflect, and it can come back to its own position. Okay, that is called ductility. So R value, more R value means more ductility. Lesser R value means less ductility. So depending on different systems, what kind of systems we are using. It could be shear wall system, it could be column beam system, it could be a column shear wall mix system. Okay, so flat slab system. So depending upon different systems or different moment resisting frame, we call it as MRF. Depending on that, we basically follow the different R value, okay, which is also stated by the code in the respective table, which is coming in the later stage. Next is the SA by G, design acceleration coefficient for different soil types. Okay, so I'll simplify it. Basically, this is dependent on intermediate and soil type. As you can see, equivalent static method currently we are dealing with, so you need to refer this particular table. Okay, so in this particular table for different time period, right? So for different time period, for different type of soil, Okay, so hard rock, medium, steep, and soft soils, and different time period regions. There are different SAYG values that is there. Okay, you need to calculate it and put it. Okay, although if you are using any kind of software like ETABS, you don't need to do anything in this. You just need to put certain parameters like time period, importance factor, Z value, R value, and all. This SAYG will be automatically calculated by the software. Okay, based upon the codal provisions. You don't need to do that, but still you need to know the back end of this particular area. Okay, so this is the thing. Now SAYG, once you are having it, okay, after that, what are the things left? Everything is over. Z is over, R is over, I is over, SAYG is over, right? So if you have these values, you can find out the AH. Okay. Now once you have the AH, there is a W also. Now what is W? So I was talking about zone factor. These are the factors. Okay, you can refer it from table 3. Now W is basically dependence on seismic weight, which I have already mentioned. Now seismic weight, how do you get it? Okay, so in the code, there are certain methods through which the seismic weight has been stated by the code. Let me just get you over there. So this is the table number 10, which is saying percentage of imposed load to be considered in calculation with seismic weight. Okay. So dead load, which is there in the structure like tiles, finishes or whatever the dead weight of the structure is there, that will be anyway there. Okay, that you need to take 100% of it. But live load, which is the human load or any sort of a movable objects load. Okay, so those loads could be variable during the course of earthquake, because most of the time you might have seen that if earthquake comes, people ask you to go, outside of the structure, or it go downstairs of the structure. So it means the structure is getting reduced seismic weight in that case, right? So if your building seismic, this particular live load is within the range of 3 kilonewton per meter square, as it is told by this code, if it is up to and including 3 kilonewton per meter square, then percentage of imposed loads, which you need to consider in your seismic weight calculation, is 25%. Okay. If it is exceeding 3, then you need to take 50%. Okay. Which is clearly stated by this table, right? So we have got the AH, we have got the W. Now, how you need to get the base shear? That we need to see. So let's get into the software. Before that, another very important thing is time period. Okay, so we have seen that SAYG is also dependent on time period. Now, how come this time period is coming? Okay, so now this code in the 21 page, 7.6.2, is talking about different scenarios of time period, right? So first is bare MRF buildings. Okay, bare MRF, as I have told, moment resisting frame means MRF. Okay, so without any masonry infills. Masonry infills means the brick block, which is called masonry infills. Okay, and apart from the brick and block, what are the things are available? Like, let's say for an example, some places we have seen that in many tech parks these days, in tier 1, tier 2 cities, Bangalore, Pune, Mumbai, Delhi, Kolkata, many places there are tech parks, right? There is a tech building where many companies are having their offices. So that sort of a building are mostly the glass facade building, because this is a commercial building and there is a look and feel criteria also. Okay, so they generally make it a glass building. Okay, so that is not considered under the masonry fields. That is called bare MRF buildings. In that case, how do you execute the time period for such buildings? That has been told by this code. Okay, so if it is an RCMRF, means RCC structure with the glass facade. In that case, what the time period you should use? 0.075 h to the power 0.75. Okay. Now, if there is a steel RCC also, steel also, it is a composite structure. In that case, or composite columns are there. In that case, you need to use 0.08 h to the power 0.7. If it is a pure steel MRF structure, steel building with glass facade, in that case, you can use 0.085 h to the power 0.75, right? Now, the next criteria, if the building is having the RC structural walls, means if the building is completely having the shear walls. Shear walls means what? If the length by depth, means depth or thickness. If the length by thickness ratio of any vertical element, that could be like column element only, like which is going downside, vertical elements, if L by D ratio is greater than 4, then it is called as a shear wall. Where we need it, where the lateral load resisting criteria is predominant. Let's say for an example, if you are operating certain project in zone 4 and 5, in that case, there will be huge lateral force, right? Because zone 4 and 5 is towards the severity of earthquake. That's the northeast part of our country. In those places, the earthquake is naturally very high. Okay, because the hilly regions are there, tectonic plates movements and different, sort of problems are there. Very close to Nepal, Bhutan, which are generally the earthquake epicenters. Those places which are very close to the hilly regions mostly, and mostly to the northeast part of our country or north part of our country, are very severe to the earthquake. Okay, in those places you have to go for the shear wall structures where lateral load resisting capacity of those particular elements are quite a bit higher, because the shear whichever is being resisted, generally if it is a huge force, the shear movement is huge, which is to be encountered. So if you are having bigger lever arm or bigger length, you can easily support the shear. Okay, so that's why the L is huge generally for the shear walls in compare with the D or the thickness. Okay, so that's why it is called shear walls, which is quite a bit different than column. Okay, it is basically a mix of column and beams. Okay, so maybe in later stage we'll come to that particular area, how the columns detailing should be done, how the shear wall detailing. That is a different sort of a discussion. But as of now, you can just keep it in mind that shear wall is basically those sort of vertical elements which are very predominant in lateral load resisting systems, and the L by D ratio should be more than 4. Okay, that is called shear wall. Now, if the building is having full of shear wall, there is no column existing over there, beams would be there, slabs would be there, and the shear walls would be there along with the infills or without infills. If such sort of a building is there, then you should use this particular formula which is being given by the code, right? For that, for calculating the time period of equivalent static method, right? Now the third point, which is the all other buildings. If your building is not falling under A and B, then you need to use the C, which is the mostly used, formula nowadays, 0.09 h upon square root of D. Now there is another thing after this code, 2016 code, there is a catch. Okay, what is the catch? In 2020, 2017 as well as 2023, there is another code has been come up which is called 16700, which is generally related to the tall structures, which is more than 50 meter in height. Okay, more than 50 meter in height, whatever structures are there, in 2023 code, if I go to the 16700 code, if you go to the seventh page, there is another set of time period has been given by the code, okay, which is only valid for 50 meter or more than that buildings. Below 50 meter, it is not valid. Below 50 meter, only you are having these 3 time periods. Okay, if you are exceeding 50 meter, then you have also this set of time periods. Okay, so this also you need to consider. Now, 1, 2, 3, 4, and 5. Total 5 time periods are there. Now, which one to take? That is the thing. If you are dealing with the buildings more than 50 meters, it is suggested to take this one. Okay. If you are operating to the building less than 50 meter, you are supposed to take this one. According to the cases, any of these 3, A, B, C. Right? Now, there is another thing. In Amendment 2 of the IS 1893 code, it has been told, if you go to this page number 6 of the Amendment 2, which has come up in the year of 2020 November, right? So if you go to that particular, amendment, if you see, there is a clause given by the amendment of the code that, yes, so 7.6.2.1, the value of EA obtained shall neither be taken to be more than that given in 7.6.2A nor less than that given in 7.6.2C. Okay, so it should not be more than 7.6.2A or it should not be less than 7.6.2C. Okay, so substitute this the following for the existing page number 23, clause number 7.7.3. So this para 2 line 1. So over here you need to substitute this for the following, for the existing. So this is the next one. Sorry, it is like this one. So page number 21, 7.6.2 C. Insert the following at the end of C. So this line we need to put at page number 21, clause number 7.6.2 C. Insert the following, means this one we need to insert at the end of C. Now 7.6.2 C, which one? 7.6.2 is this one, and C is this one. Now after C, we need to insert this clause. Okay, which clause? This is the clause that value obtained in value obtained TA neither to be taken more than that given in 7.6.2a. Which one is this? 7.6.2a means the upper limit of your value should be this. It should not be, it should not be more than these values, whatever the considerations are there. Okay, and it should not be less than that given in 7.6.2 C. It should not be less than this. Okay, so it should not be more than this, and it should not be less than this. So this is the lower limit and this is the upper limit. Okay, so what does this particular clause means? In any project, in any structures which is less than 50 meter in height, you should always calculate all three of these time periods. Okay, if it is more than 50 meter, directly 16700. But if it is less than 50 meter in height, you should always take these three time periods, and you should take the higher one as this and lower one as this, and you need to take somewhere in between. Okay, so there are three values, either any of these three, this one and this one. If your building is not having the structural walls, then you directly take this one. This is the most better way to do it. Okay, if you have the structural walls also, you need to calculate all three of this. Okay, and the highest one would be ruled out, the lowest one would be ruled out. If it is the middle one is this one, then you need to take this one. Or if the middle one is this one, then you need to take this one. Okay, it should not be less than this, it should not be more than this. Okay, this has been told by this code in the amendment as well. Okay, so this is the part of the time period sector. I know this is little confusing. Don't get confused. It is, you need to, study, and you need to revise quite a bit of time. You need to implement, then you will get it. So I'm simplifying it. Don't worry. Okay, so mainly the time period is basically required for static earthquake analysis, where the time period will help us to get the SA by G, as well as it will help us to understand the nature of the structure, right? What kind of fundamental behavior or movement it is doing, or oscillation it is doing. Okay, so for that SA by G calculation, whatever the time period we are calculating, if the building is more than 50 meter in height, this code can be followed straight away, because this code has come up after 2020, after this. Okay, so directly you can take this. If it is less than 50 meter, then you can take these three values, this one, and this one, by following that this particular building which you are doing is having RCC shear wall, and like all over, and then you can take the value. Let's say if this A, B, and C. So C is the lowest one. This is the value should be greater than this, or at least equal to this. Okay, this is the most critical value, because lower the time period, higher the base shear, right? Because if your time period is lesser, the building is moving less, so the forces that is coming is more. Okay, so whenever you are having the C, this is the C, right? So C is the lower value, A is the upper value. Now you could be taking somewhere around B, or you can take C. You should not take the higher value always, because if you take higher time period, the base shear will be drastically reduced. Okay, that should not be done. You should take little conservative side. Okay, you could either take C or B. Okay, or if the B is more than A. Okay, if the B is more than A, then automatically the B will rule out. Okay, because it could not be more than A. So in that case, directly you can take C. Okay, so you need to see all these three values, and you need to take the the immediate value after the lowest. Okay, immediate value after the lowest or the lowest. Okay, that way. You should not take the highest value, because that will be little underestimation of the force. Okay, so this way you need to consider the time period. Now, by discussing all of this, another thing is very important, how to implement that in the software. So this is one of the ETABS model that I have opened. So I'll take just a new model to you so that it could be very easy for you. Just a built-in settings I'm using. Okay, India and some Indian code. All right, so this is the thing. Now, let's say for an example, a flat slab structure, just a template model I'm taking. Okay, just to let you understand the topic first. Okay, you should be very thorough with the subject first before applying that in the software, in any software, in anywhere. Okay, please be thorough with the concept first, right? Because otherwise, what will happen? You will do blindly, which is not correct. All right, now let's, for an example, let's get into the define load pattern. Okay, now here we'll be taking EX, which is static earthquake, right? So seismic, here we'll change the code, IS 1893-2016. So similarly, UI means this is the static earthquake we are dealing with right now. Okay, now in the EX, there is a modify option. Now here, what you need to do, that is the main thing. Whatever we have studied so far, we need to explain over here. So it is an X side, so Y side will be unchecked. We should don't need to take the Y side. Okay. Now X direction plus eccentricity minus eccentricity. By default, there would be certain torsion in the structure. So for that, 5% torsion has been, or eccentricity has been considered by the building automatically. Okay, or by the software. That is the by default value that you need to take. So these three should be checked, and this should be 5% by default. Okay, mostly the things are okay with the 5%. If it is more than that, then that you need to check in torsional irregularity check at the later stage. Okay, now story range, generally it is from base to top story. By default, there are 4 story in the software, so we are getting 4 story over here. Okay, response reduction factor, as I have already told you guys, response reduction factor is basically based upon the ductility clauses. Okay, so this is the response reduction factor table, table number 9. Okay, as you can see, different moment resisting frame is there, structural wall system, different dual systems. How you want to idealize your structure, based upon that, within the range of 2 to 5, the values will be changed. Okay, 5 means all the elements are ductile. Okay, 4 means few elements are ductile, few are ordinary or non-ductile. 3 means all are non-ductile, like that. You know, if you are having more R value, more ductility would be offered in the structures. So for an example, as of now, we are taking 5. Now the seismic zone factor, let's consider this building as zone 3. Okay, so this is 2, zone 2 means 0.1, zone 3 means 0.16, zone 4 means 0.24, and zone 5 means 0.36. Let's consider this building in zone 3. Site type will be given by the geotechnical consultant, whomsoever would be there in their site soil report. You will be able to understand what sort of a soil over there. Okay, it could be a rocky soil, medium soil, or soft soil. So rocky soil means you are having grade as 1, medium means 2, and soft means 3. Okay, so based upon that, site type would be given. As of now, we are taking medium soil. Now the importance factor, as I have already told, critical lifeline structure like hospitals and temples and all, you can take 1.5. If you are having the buildings where the occupancy is more than 200 people, then you can take 1.2. Otherwise, you can take 1. Right. Now the most important area is time period. Now there are 3 methods. Program calculated means if you are modeling the machinery walls, then you can directly take program calculated. You don't need to calculate the time period and put it. Approximate, you can take it for without infill wall machinery infill wall panels, whatever the approximate values, like let's say for an example 0.075, 0.08. Okay, if you are your building is coming under this particular region of the values. Okay, because H is known to the software, right? So you don't need to really give anything. You just need to give these factors. Okay, so if your building is coming under this particular value, then you can use the approximate method and you can change this coefficient and it will calculate the time period on its own. Other than that, if you are doing it, then you need to go for user defined and you need to calculate the value and provide it. Since it is a column structure, we are following the method of T. Okay, as of now. Okay, so because this is the most conservative one, the amendment has told the time period should not be less than this. So this is the most lowest time period. Lowest means the highest base shear. So as of now, we'll take 0.09. H means how much is our H that we need to take, divided by square root of D. Now, what is D? D means the direct dimension of the lateral sides. Okay, let's see if we go to the story. So this is the draw menu, dimension line, and this is the dimensions, right? So 21.946 and 21.946, since it is a square side. Okay, so 21.946, right? So I'll just open the calculator. So 21.946, which is almost 22, you can take. Okay, so 22 point, yes, this is square root, right? So 4.69. Okay, so 4.69, now 0.09 into H. H is how much? H is 14.63 or 15, we take it. Okay, so 15. 0.09 multiplied by 15 divided by 4.69, which is 0.28. So 0.28 is the time period, right? So it would be the time period for both the cases. Okay, 0.289. We'll change this to this, and the rest of the things will remain same. Okay. Similarly, over here also it is a square building, so both the side would be same. But in your case, whatever the projects you will be doing, based upon that, you need to calculate this particular time period properly. Your dx and dy could not be the same. Okay. So whatever we have calculated for x, similarly we have done for y also. Okay, now make it okay. Now go to the mass source. Now here what we did, these two areas will be giving you the AH. Okay, whatever the requirement of AH, that will be followed by this. Okay, that will be okay with this. Now we need to calculate the W also. For that you need to go to mass source, modify. You need to check this too, because we are not software by default calculate the self weight. Self weight you don't need to calculate. You need to just calculate the this element self mass, you can uncheck. Okay, and you can take the eccentricity from here and specify to the load patterns how much mass you should consider. Okay, that you need to do it. So dead load is 100%, live load is 25%. Okay, make it okay. Okay. Now we'll be simply, if you run the analysis from now, you will get the value. Before that, one more thing you need to do. That is basically you need to go to the base. And currently, what I by default, these bases are basically hinge support. But ideally, it should not be hinge support. It should be always idealized as per fixed support. Although it is not a fixed support also, because we are allowing the settlement in the foundation, right? So it cannot be a fixed support. Fixed support means infinite stiffness. There is no, there is nothing. There is no settlement, no deformation, nothing. But actually, that is impossible. Okay. So what we do is we basically make it fixed support as of now. Whenever we'll do the foundation design, after that we'll do the soil structure interaction. Okay, in that case, we'll be able to get the exact behavior of the columns. As of now, we'll be keeping this as a fixed support and run the analysis. Now, once you will run the analysis, we'll ask you for the model to save. We'll just save it. Okay, we'll just save it over here and we'll run the analysis. I have not added any load. Whatever the self weight is there, based upon that only it will be calculating. Ideally, what you should do, you should add all the loads, sections, properties, and everything. And then you need to basically do this particular analysis. Since we are just focusing on that quick, I'm just showing you how to do it. So go to the display, show tables. From here, analysis, structural output, and base reactions. You need to click on this. Select load cases, you click on EX and EY. Okay, and make it okay. As you can see, there are certain EX and EY value that you have got it. How much is that? For EX, it is FX. For EY, it is FY. Y1, 2, 3 is nothing but the eccentricity. Although in all the places, the values are same. Okay. So 611.43 kilonewton is your base shear due to the earthquake. Okay, that is coming in the static method. Now, similarly, we need to do the dynamic method also. How to do that? Dynamic method is nothing but everything will be, similar. Just the execution or the distribution mechanism of the forces would be changed to a dynamic manner. Okay, currently what is happening, if you draw the diagram of the force distribution, it will be somewhere like this. Let's say, for an example, if this is the structure, okay, this is static method. Okay, this is getting bigger at the top because the maximum responses are at the top. Okay, so like this, it will be bigger. Okay, so this is like this. So these are having, let's say, for an example, F1, F2, F3, like that, and so on. And there is a opposite that is called summation of F. All right. So this is basically the value that we are getting generally in the case of static distribution. But in case of dynamic distribution, this is not the scenario. It is based upon the maximum responses that we are getting. Based upon that, it will be giving you the responses of other modes as well. So it is basically a dynamism or dynamic effect. It is not a static, you know, distribution of the forces. Okay, dynamic means it is like very natural, or I would say it will be very, it will be very impactful. It is also having certain impact forces. It is the distribution mechanism of the dynamic forces. It is having the static one is equally having all the forces and equally having the responses. It is not like that. Dynamic response spectrum analysis is there will be a spectrum of responses on that particular forces, and whatever the maximum response is there, based upon that, it will give you the forces. It will give you the values. Okay. How to do that? Simply you need to unlock the model, go to define back again. You need to go to functions and response vector. Okay. To click on 1893-2016 and add new function. Okay. From here, you can give any name you want. Okay. I'll just give Seismic zone 3, importance factor 1. This is 2, this is 5. Nothing else you need to do. Damping ratio will be remain as 0.05 since we are dealing with, we are dealing with RCC structures. Okay. Now go to defined load cases, add new cases, and response spectrum method. So here you need to do the Spec X or Spectrum X or whatever name you want to give. Add function you need to change. This is the default scale factor, which is nothing but the G value. Okay, gravitational constant value. Okay, acceleration U1 function this, and then you need to go to diaphragm eccentricity, and by default, as I have told, 5% eccentricity should be taken. Similarly, you can make a copy of it. This will become Spec Y. This will become U2 because direction should be changed. Okay. Always remember in ETABS, normally we know X, Y, and Z, right? So in ETABS, it is 1, 2, and 3. So X, Y, Z is becoming changed to 1, 2, 3. Okay. So that is the change that we generally follow. So that's why in ETABS, we always see 1, 2, 3 axis or coordinates. U1, U2, E3, like that. So it is not like something different. It is the same thing. Just the naming is changed. Okay. Now we need to make it okay. Another very important thing. Okay. Since I have taken this model, which is a prototype, a model that is called flat slab model. For flat slab, the R value should be always 3. It should not be 5 as per the code. So do not consider the, systems which I have taken. This is just for showing you guys. This is not the actual system that or actual project that I am doing. How the methods should be done, how the steps should be followed, that I am basically trying to guide you at. Okay. You need to take the proper methods or proper values from the code as per it is. Okay. If it is a flat slab structure, you need to follow the certain rules. Okay. That has been told by the code in the same place where in the R value table. So if you go to the R value table, you will get the flat slab. This is the flat slab structure, right? So you need to take 100% forces should be, resisted by the RC structural walls. Okay, and the R value is only allowed as 3. If it is a flat slab structure, so you cannot take 4 or 5. Okay, perimeter RC SMRF should resist 25% of the forces independently. All these parameters should be followed. Since I am just showing you, I am not bothering about the systems of the structure. I'm just telling you the properties and the methods that you should use for any normal structure. I'm considering this structure as a normal structure. Okay. Now go to the define load cases. It is already created, right? Now make it okay and run the analysis. Now you will be getting what? You will be getting the dynamic base shear, which will be always lesser than the static base shear because of the infill panel, which I have started this session with, because of the infill panel parameters. Since that is not considered in dynamic, right? Dynamic, what are the parameters we have given? We have given the soil type, zone factor, everything, but we have not given any time period. The time period is considered based upon the model that we have had. Okay. In this model, there is no infill panel. Okay, no wall, nothing we have considered. We have considered beam, column, slab, shear wall. That's it. But walls would also be there. That is not considered because of that only. The dynamic base shear value always comes as lesser one, as you can see. Okay, 192 is coming, and this is coming as 611. Okay, so it is quite a bit lesser. Now, what you need to do is you need to match the base shear, okay, which is called scale factor calibration. What you need to do, whatever the EX value is there, divided by the spec X value, multiplied by the whatever the existing scale factor is there. You will write down somewhere, let's say in Paint, you will write down, or in any Word file or Excel, anywhere you can just do this. So EX value, whatever the EX value is there, EX value is how much? 611, right? EY is also 611. Spec X is how much? 190. Spec Y is how much? 192. Now EX upon Spec X divided by EX divided by Spec X. This is bracket multiplied by 9806, right? Why 9806? Because that is the current scale factor that we are having, which is gravitational constant, right? 9806.65. Okay, so 31,207.62. Okay. Similarly, spec Y. Similarly, spec Y, how much? Spec Y is the similar one, same scale factor because the values are same. So I'm not doing it again. Just copy from here. Ideally, it should not be always the same. Okay. If it is not coming same, you will say, no, sir, it's not coming same. It's not like that. Since it is a square building and everything, that's why it is coming same. So you need to mainly follow the steps and the methods. So make it okay. And redone the analysis. Okay. Now you will see same table. Now it has become the same almost, right? So this is 611, this is 612. Okay. So what we did, we took the EX value and we have calibrated that with the spec X value. Okay. What what it basically happened? The base shear, which has been given along with the infill panels, that has come up with the dynamic. Okay. Now, at this moment, what we do, only static base shear is being calculated because of this reason only, to get the effect of infill wall panel. Okay, as a stiffness. Now, what you need to do is you need to simply take spec X and spec Y into the design. If you do the design, that time EX and EY combinations would not be there. Okay. Whenever you will be doing the design, only spec X and spec Y combination would be a part of it. Okay. There would not be a spec EX and EY combinations after the calibration of the scale factor. So make sure whenever you will be doing the design after this, the calibration must be done. Okay. And the dynamic combinations only to be taken, because earthquake is dynamic in nature. We all know that. Okay. So that distribution is much more realistic than the static base shear. Okay. Although the static base shear magnitude and values are much more proper than spec X and spec Y, because that includes the stiffness of the infill panels as well. Okay. We are taking the value from EX and EY and matching with the spec X and spec Y and adapting the distribution mechanism of the spec X and spec Y and following the design. Okay. This is the fundamental area between static and dynamic linear analysis of earthquake as per Indian code. Okay. We have, first of all, what we have done, we have understood the basics and overall aspects of the code what are the different formulas that we need to do, whatever the different calculations that we need to follow, how we should reach to the application stage of the software of static base shear or static analysis. Once that is done, then we are entering into the dynamic analysis. Now there is a place in 7.7.6.2, if I am not mistaken, in this code clause that has been told that where you need to do the dynamic analysis. It is not like everywhere you need to do the dynamic analysis. Yeah. So this is page number 23. If you go to 7.7.1 clause, this clause is basically telling you where you need to do the dynamic analysis. If there is a small structure, within 15-meter height in seismic zone 2, you don't need to do dynamic. Only static base shear analysis is enough. Okay. So that clause will also guide you towards that how you should adopt the dynamic analysis, when you should do it. Okay. Another thing is there is a check also that you should do, which is called story displacement and drift check due to earthquake. Okay. So if you go to this story response for maximum story displacement, from here you need to change it to Spec X. Okay. So this is the value that is coming. So 40 mm is being deflected due to the Spec X for entire structure. Similarly for Spec Y. Okay, so this is the thing. Now, how you should do it? H upon 250. This is the formula or the limit for the displacement check of earthquake. Okay. If H upon 250, H means total height of the structure divided by 250, this is your limit. If your this value is less than this, then your building is safe within the limit. If it is more than this, then you need to change the stiffness at certain area. How to change the stiffness or revise the stiffness? You need to increase the column size. You need to orient certain column in such a way. You need to introduce certain columns. Different things you need to do. Okay, so this is the check that you need to do for displacement. For the drift also, there is another check. So this is to be changed as maximum story drifts. Okay, so similarly, Spec X and Spec Y you need to check. You can check the different stories also, because drift is more crucial for earthquake than displacement, because drift is basically the relative displacement between two stories. Okay, so sometimes what happens between base to first floor, maybe the drift is not coming, but third to fourth floor it might come. Okay, each and every individual level also you can check. So let's say base to story one, then you can check base to story one to story two, like that. Okay, so everywhere it should be less than 0.004. Okay, that is the value, that is the limit. Okay, story drift should be within the limit of 0.0004. 0.004. Okay, this is the limit for story drift. So these two are the checks that you should do for earthquake analysis. You should also always do it for Spec X and Spec Y only in unfactored manner. Okay, so this is all about it from my end today. Yes, Pavan, I think that's all about it from my end. If you have anything to discuss, you can share it accordingly.
Hi, sir. From which code we have taken drift limits in displacements? He's asking the
Ah,
question, sir.
yeah.
Shiv
So
Prasad.
these limits are also given by IS 1893 code. Also in the IS 18700 code also it is given, but you can get it from the IS 1893 code. These limits. See, nowadays, I would like to also add on another point. Nowadays, it's very simple and easy to get the codal clauses. Even in our days, it was little difficult because we need to find out the code and all those stuff. But nowadays, it's simple. You need to just open the ChatGPT, Google, Gemini, or any sort of AI tool, Claude, Grook, anything you open, and just write down that where are you getting from this particular displacement and this drift clauses. It will give you including explanation of everything. So learning is becoming very simple. And to be honest, although the sudden judgment you cannot take it from the chat, from that particular uh, from the chat GPT, you cannot you cannot do the design of a building. That is definitely not possible at this moment. But at the same time, the works, the whatever the repetitive works were there, that has become very easy. Okay, or that has become very handy to us, to finding certain clauses or to get certain access of certain codes, certain clauses, certain points. some references, that has become very easy and very handy. So please get the maximum benefit of it and learn to the fullest and get the maximum benefit of the software also. Nowadays, CSI is also like who is the developer of the ETABS software. They are also developing it very frequently. Every year, almost they are coming up with the versions. Okay, so why it is happening? Because of this only. Like they are also trying to incorporate at maximum as possible. Okay. Anyway, always there are certain small bugs, problems, and incompetencies with the software because that is also developed by an engineer or certain human being by like us. Okay, but at the same time, these are like for our work to make it more easier. They are also striving so much. So I was just listening to some some area that in couple of years, maybe in the coming years only, that Revit and the ETABS and other softwares also whatever are there, those are also coming with the inbuilt AI integration. You just need to keep the which has also already come up with certain softwares, but AI integration is going such a rapid way that it will also be coming up in our sort of software. So you should be always very welcoming to the AI, to their platforms, to generative AIs, to different kind of areas, to make your work easier, to make your repetitive work easier. You should not do the repetitive clerical works every time. You should always be very smart worker in this kind of areas. So this is the suggestion from my end. Okay,
So
great.
thank you so much, sir, for such an insightful and valuable session.
Thank you.
The way you explained the concepts were really clear and practical. I'm sure all the participants gained a lot of useful knowledge from this session. And thank you all the